Chapter 2.2 Day 1 Characteristics of Quadratic Function. Vertex form of quadratic function is fx equals a times x minus h squared plus k. Again, the h is used to move the graph left or right, and k is used to move the graph on up and down. The a should not be equals 0, because if a becomes 0, then this whole thing becomes 0. All you left with is just simple a number, and that will not be a quadratic function anymore. So that's why a should not be equal 0. An axis of symmetry is a line that divides a parabola into mirror images and passes through the vertex. Again, the vertex is going to be h comma k, because the vertex of fx a times x minus h squared plus k is h comma k. The axis of symmetry is the vertical line. So remember, it's not a point, it's a vertical line which passes through the vertex and is a straight vertical line. Previously, you used transformations to graph quadratic functions in vertex form. You can also use axis of symmetry and the vertex to graph quadratic functions written in the vertex form. Let's do example number 1, using symmetry to graph quadratic function in vertex form. Graph fx equals negative 2x plus 3 squared plus 4. Label the vertex and axis of symmetry. So in this case, a is going to be 2, h is negative 3, remember the opposite sign, and k is 4. Now h and k is the vertex, and we are going to plot the vertex. So negative 3 comma 4 would be this point right here. And remember, there is a negative 2 in the front. So anytime you have a negative, it means it's a reflection over the x-axis. We are going to make 2 more points, and we are choosing x equals negative 2 and x equals negative 1. We choose these numbers very carefully. Whenever we get the h value or the axis of symmetry value or x value, which is negative 3, either you choose 2 points on the left of it, so it means either you choose negative 2 and negative 1 for x, or you choose negative 5 and negative 4 and negative 5, and you make a graph or curve on one side and mirror on the other side. Because it's a symmetrical figure, so whatever the points you're going to get on this side, the same is going to be on the other side. So let's make the points or y value when x is negative 2. We are going to plug it in for x. The x value is negative 2 in the given equation, that is right here, plus 4. So that's going to be negative 2, 1 squared plus 4. And it's going to give you negative 2 times 1 is negative 2 plus 4 is 2. So our point is going to be negative 2 comma 2, which is this point right here. Now we are going to use negative 1 for x value, and we are going to use and plug it in here in the given equation. So negative 1, f of negative 1 is negative 2, negative 1 plus 3 squared plus 4. And negative 2 times 2 squared plus 4. So remember that 2 square is going to be 4, and 4 times negative 2 is negative 8, and negative 8 plus 4 is going to be negative 4. So our point is going to be negative 1 comma negative 4. So negative 1 comma negative 4 is going to be 1, 2, 3, 4, this point right here. So I'm going to plot the negative 1 comma negative 4 here. Now we are going to plot the point for the axis of symmetry. So remember, axis of symmetry is x equals h, which is -3. So axis of symmetry is this line, and that is a vertical line passing through -3. So this is my vertical line. I got the one side graph, that is this side, and I'm going to mirror the points on the other side of axis of symmetry. So if this is one point from here, this is going to be the mirror of this point is this point, and 1 2 from here, so mirror is this point, and then you're going to get the graph that is open down because of the reflection. So draw and plot through the plotted points. So that's going to be your open down parabola for fx equals -2 x plus 3 square plus 4. And also, if you notice that this is the 2 in the front, it means it's a vertical stretch graph. And the pattern for this graph is, normal graph is 1 comma 3 comma 5. And since it's a -2 in front, so you're going to multiply the -2 inside, and the new pattern for the graph is going to be down 2, down 6, and down 10. So you can see that from the starting point is going down 2 over 1, and then from this you're going to go down 6. So 1 2 3 4 5 6 over 1. So that's the pattern, because normally we have 1 comma 3 comma 5 for parent graph. We multiply it by a, and then you're going to get the new pattern for this vertical stretch or vertical shrink graph. Now you're going to pause the video and try the U-try problem. For the U-try problem, we are going to compare it with the standard form of vertex function, and we are going to see what is our h and k, or vertex. So I can compare that the h is going to be compared with the -1, so it's going to be -1, and k is not there, so it's -1 comma 0. Remember, for the h value, so h value we're going to check the opposite sign, so it's -1 comma 0. For the axis of symmetry, you're going to choose x as -1. So now I'm going to plot -1 comma 0, which is the vertex, and this is this point right here. Axis of symmetry is a line, so it's x equals -1 line. So I'm going to draw this line as well, and now I'm going to find two more points to make a full graph. So you're going to choose the point either left of -1 or the right of -1, which means that either you're going to choose 0 and 1 to find two more points. Remember, we are going to graph only one side of the graph, and the other side will be its replica, or its mirror point, mirror image of this side, and it's going to be a open down parabola because of the reflection negative sign. Now I'm choosing the 2 points that are on the right of -1. So I'm going to choose x equals 0, which is this point, and I'm going to choose x equals 1. So I'm going to find now what is the y value, or the function value at x equals 0. So I chose x equals 0. I used the x0 and plugged it into the original equation. So f of 0, which means y, equals -3, 0 plus 1 square. 0 plus 1 is going to be 1. 1 square is just 1. So my point is going to be -3. So my point is 0 comma -3. So which is going to be this point right here. So 1 2 3 0 comma -3. So 0 comma negative 3, and the next point is going to be x equals 1. So x equals 1, you plug it in here for x value. F of 1 equals negative 3, 1 plus 1 square. 1 plus 1 square means 2 square, and 2 square is 4 times negative 3, and that is negative 12. My next point is negative 1 comma negative 12. That point is not in the graph. We can assume that this is 1, and negative 12 is down here somewhere. Just assume that this is the point negative 1 comma 1 comma negative 12, and you're going to make a graph by connecting these points. The other side of the graph is just a mirror of this side. So this side is going to be a mirror of the of this side. So my next point is going to be this one. So that's my point right here, and for the mirror of this point is going to be right here. And you can see that if you follow the pattern, you're going to use 1 comma 3 comma 5, and in front of this you're going to normally multiply a, and in this case a is negative 3, so here you're going to multiply with negative 3 and figure out the pattern for this graph. My pattern is going to be negative 3 comma negative 9 comma negative 15. So you're going to start from vertex. So you're going to start from the vertex, and you're going to go down 3, down 9, down 15, and that's going to be your graph. Remember, the pattern is this one for the parent graph. If the a changes, then you're going to multiply the a in the front, and you're going to get a graph that is vertically stretched graph from the parent graph. Now let's discuss standard form of the quadratic equation. And the standard form for the quadratic equation is going to be fx equals ax squared plus bx plus c, where a is not equal 0. So remember, the a is the first term that should not be equal to 0, because if the a becomes 0, then the square term will be gone and we will be left only with bx plus c. That is not a quadratic equation or function anymore. Bx plus c is a type of mx plus b, which is a linear equation. So it's important to have x squared term because we want to discuss the quadratic function. Next is standard form can be derived from the expanding the vertex form. So the vertex form is you remember, this is fx equals a times x minus h squared plus k. Now you want to expand this vertex form, and you want to get the form that is in the standard form. In order to find out or expand this equation, we are going to solve the x minus h squared. So I'm going to solve the x minus h square on the side here. So x minus h square. X minus h square is x minus h times x minus h. Distribute or use a FOIL. So it's going to be x times x, which is x square. X times h is negative xh. H times x is negative xh, and negative h times negative h is h squared. Again, we're going to h time x times x is x squared, x times h is hx, and negative h time negative h should be, oh, this is should be positive h square, so it's going to be positive h square. Now I'm going to use this term and combine the like terms here. So xh minus xh would be 2xh plus h square. Use this expression for x minus h and plug it in for x minus h square. So here I'm going to plug it in. And now I'm going to use the distributive property. And after distributing a inside, I got ax square minus 2axh plus a h square plus k. Now I'm going to group the like terms. Like terms are those that have a same variables. So I'm going to have this one by itself because there is no x squared term in this whole equation. It's just this one. And there is no x term either. So I'm going to write this two separate. These two terms are like terms. You're gonna say, how is these two are like? Just remember there is no variable with them. So it means that this is also considered as constant and this is also constant. So just like 2 plus 3. So they are like terms in that way. So here we have ax square plus 2ahx, and this is considered as constant. We can put it in same bracket because it's same terms, so they're constant. So let b is the term that is next to x. So the b is going to be negative 2ah. C is ah squared plus k. So in that way that this my term will be ax squared as it is. I assume that this is b, so I plugged it in b here for negative 2h ah, and for this one I plugged it c. So my equation will be fx equals ax squared plus bx plus c. So now let's discuss the bottom part of this. So if you notice that this allows you to make the following observations. You can see that A is A, but for the B, we assume that the B is negative 2AH. So if you want to find the H from it, then you're going to divide the negative 2a on both sides, and then you're going to get the h value, that is negative b over 2a. Again, we assume that the b is equals negative 2ah. Divide negative 2a on both sides, you got the h as negative b over 2a. C, we assume that this is ah squared plus k, and that also called the y-intercept. Y-intercept is that value of y where x is 0. So you can plug it x as 0 here. So x0, x0, x0. So this whole thing becomes 0. And what you're left with is ah squared plus k, that is c right here. And that is called also y-intercept. So the y-intercept will be c. Now let's discuss some of the properties of standard form of quadratic function. So fx equals ax squared plus bx plus c is a standard form. You're going to use this function to discuss the properties of the graph. Let's discuss this when a is greater than 0 or a is positive, how the graph is going to look like. So if a is positive, the parabola opens up, and if a is negative, it's going to opens down. So in this case, we assume that a is greater than 0, so the parabola is going to go up, and the y-intercept is going to be, so y-intercept in this case is 0 comma c, so it's always c. So let's see if the parabola starts from here. Let's see. The pattern is going to be to graph is go up 1, up 3, up 5. So it's going to go up 1 and then 1, 2, 3, up 3, let's see. And that's going to be your open up parabola, where is vertex is this point, and wherever it cuts at y-axis, that is going to be your y-intercept. Again, if a is positive, then it's going to go opens up, and the vertex is going to be minimum because it's all the way at the bottom of the graph. For a is negative, in this case a is negative, anywhere it starts from, so let's say if it starts from here, it's going to go open down. The pattern is still the same, go down 1, down 3, and down 5. So here is going to, let's say, down 1 and then down 3. The parabola is going to go open down, and the vertex is going to be maximum because it's all the way on the top of the parabola, and your y-intercept is always going to be 0 comma c because that is where the x is going to be 0. The graph is narrower, or it's called vertical stretch. In other words, if the a is greater than 1, so if it is 3, 4, 5, 2, which is greater than 1, then the graph is going to have a vertical stretch, or is called narrow graph. It's going to be wider graph if a is less than 1 but greater than 0. So anytime if a is 1 over 2, 1 over 3, 0 0.5, 0 0.4, then it's going to be a wider graph. The axis of symmetry is x equals negative b over 2a. Remember, axis of symmetry was x equals h. Now the h value is negative b over 2a, so x is negative b over 2a. The vertex is this point, which is negative b over 2a, and to find the y coordinate, you're going to use this x value and plug it for the function. So let's see if the function value is fx equals ax squared plus bx plus c. Then for the x value b over 2a, you plug it in for x and you will get the y value. For y-intercept is always is the constant of the graph, that is c. So 0 comma c is always the y-intercept.